Hello everyone and welcome to day 17 of the Jamb Physics in 40 Days series. This series is brought to you by Oya Learn, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you will be able to gather all the necessary skills and tools that will help you to ace Jamb Physics. So peradventure you are preparing for the Jamb exams and one of the subjects you have selected is physics, then this video is specifically made for you. So trust me, you don't want to miss any video in the series. So do well to check out the videos from day 1 up until today, which is day 17. I'm saying this again, you do not want to miss any video from the series. Now, this is because in every video, we are looking at the individual topics that are in the Jamb Physics curriculum. So we are looking at the topic, explaining, giving a crash course to it, and then solving multiple past questions from Jamb on those topics. So there's no way you will not be able to gather enough knowledge to ace your Jamb Physics. We are promising that when you go through all of this, you should be able to get 90 plus in Jamb Physics, as long as you do it religiously. So please check out the videos and also don't enjoy it alone. Ensure that you share it amongst your friends who are also preparing for the exams. Let's help everyone ace their Jamb Physics. So please like the videos, share the videos, and also do not forget to subscribe to the channel. It's very important to subscribe because when you do, you are helping us to be able to make more helpful videos like this. So hit the subscribe button and also click the notification bell icon so that you get alerted when we put out the next amazing content. And also, I'd like to implore you that you'll find a link in the description box that takes you to where you can download an app known as Exam Phone. Now, that app is created in such a way that it makes your learning experience like a game, where you solve questions in different levels and it's so exciting. It makes your learning experience become a fun one. So please click that link and download the app either from the Google Play Store or from the Apple Store depending on your device. That app has all the subjects that you are taking, so whether it's math, English, physics, no matter your subject, the app is created to make your learning experience fun. So please download and register and enjoy your learning experience. Now let's get down to business for day 17. Day 17 is about Vapours. Now, what Jamb expects of every candidate taking the exam as far as Vapours goes are listed here. Now, they expect that every candidate should be able to distinguish between saturated and unsaturated vapor pressure. Now, when we are saying saturated vapor pressure, it means that it is at equilibrium with the atmospheric pressure. And the moment it takes in more pressure, it begins to condense back to its liquid phase. Remember, at that point, it is supposed to be at the boiling point where it's going into steam, right? Where liquid becomes steam at that point. So if it goes beyond that, it will then condense. And that's what creates things such as your precipitations, your fog, mist, and the likes. So you should be able to distinguish between them when we have saturated pressure and unsaturated vapors. Saturated vapors and unsaturated vapors. Now, you should also be able to relate saturated vapor pressure to boiling point. Now, I mentioned that saturated vapor is when the pressure is at equilibrium with the atmosphere, right? So you should be able to tell when a liquid gets to its boiling point based on its saturated vapor pressure, because that's the point where it is going to be the same with the atmospheric pressure, right? And at that point is what we call the boiling point of a liquid. Now, you should also be able to determine the saturated vapor pressure by the barometer tube method and also be able to differentiate between dew point, humidity, and relative humidity. Now, even though these are very separate, there are some linkage between them, so you should be able to identify clearly what do we mean by dew point, what do we mean by humidity, and what do we mean by relative humidity. As a short point here, when we talk about humidity, for example, that is the quantity of water vapor that is present in the atmosphere. But when you are comparing it now and you are talking about relative humidity, you are looking at the content of the water vapor that is in the atmosphere at a particular temperature with respect to the maximum possible at that same temperature. So that's the difference between humidity and relative humidity. And you should also be able to do some minor calculations on relative humidity. And then finally, you are expected to be able to estimate the humidity of the atmosphere using the wet and dry bulb hygrometer. Now, some students sometimes confuse hygrometer and hydrometer. So note that for when you hear the word hydrometer, you are looking at a different thing entirely. This is not for humidity. That one is for density. So when you are looking at the density of a liquid, we use hydrometer. But when you are looking for the relative humidity of an atmosphere, then we use what we call hygrometer. So even though they may sound close, they are different and they are used for different things entirely. So this is what is expected of you, and we'll be looking at some questions where these objectives are highlighted. We'll touch them as we solve those questions. So please get all your materials ready and let's solve some past questions on vapor. This question from the 2005 UTME is asking about how to read a wet and dry bulb hygrometer. So let's kill two birds with one stone. Now in the question, we're asked when the temperature difference between the wet and dry bulbs of a hygrometer is high. This indicates that. Now, when you see that the temperature difference between the wet and dry bulb of an hygrometer is high, that tells you that a lot of evaporation is taking place. And this only happens when the air is dry. You need dry air for evaporation to be more rapid, right? So in this case, that tells you that if the air is dry, that it is not humid. So that indicates that the relative humidity is low. So in this case, the answer is D. Now, to the second bird. That is, we can reverse the same question and then say when the difference in temperature between the wet and dry bulb is small. So in that case, that is, evaporation is not taking place rapidly. That is, the air is humid. In that case, the answer would be that the relative humidity is high. So you see, depending on how the question is put, you too can read a wet and dry bulb hygrometer. But in this case, the answer is D. At low humidity in an environment, the human skin is usually... Now, this is a very direct question that we can just pick. When we say the environment, in an environment, the humidity is low. That means that the amount of water vapor present in the atmosphere is very low. So that is, the atmosphere is dry, right? So when the atmosphere is dry, the result on the human skin is that it will make water molecules to easily evaporate from the skin, leaving it also dry, right? And that will also make it rough texture, to give it a rough texture. So in this kind of situation, the skin should be dry and rough. So we go with option C. In this 2008 UTME question, we have to find relative humidity of an atmosphere at 27 degrees Celsius. Now, earlier on in the video, I did mention that when finding the relative humidity, you have to do the ratio of the pressure, the vapor pressure at that temperature to the maximum possible vapor pressure at that same temperature. So let's apply that to solve this question. So the relative humidity would therefore be, now we're going to look at the saturated vapor pressure at 27 degrees Celsius for that atmosphere at that time, which is 18 millimeters of mercury. So that will be 18 divided by the maximum possible, because the question goes on to say that and the saturated vapor pressure, that is when the vapor pressure gets to the maximum, the saturated vapor pressure at the same atmosphere of the same temperature is 24 millimeters of mercury. So 18 divided by 24. So we're going to leave our answer in percentage, so we multiply by 100%. Now, when we break this down, we see that both of them are divisible by 6. So 6 goes here 3 times, 6 goes here 4 times. Now, 3 divided by 4 would give us 0.75. So multiply by 100%, and this gives us 75%. So the answer here is option C. In this question from 2010, I will ask that a vapor is said to be saturated when? Now, when we say vapor is saturated, it means that the rate at which an evaporation is taking place is the same as the rate at which condensation is taking place. That is, the amount of molecules that is becoming vapor per second is equal to the amount of molecules that are becoming liquid back again in the same second. So let's look at the options and see which one actually describe a vapor that is saturated. So option A says a dynamic equilibrium exists between the liquid molecules and the vapor molecules. Now this is true. This also supports what we have said about vapor being saturated, in the sense that we see here that there's an equilibrium. That is, the liquid molecules is the same as the vapor molecules. That is, in the same second, those becoming liquid is the same as those becoming vapor. So this supports that. However, let's look at the order so that we can be absolutely sure. Now B says a dynamic equilibrium exists such that more molecules return to liquid more than they are leaving it. So at this case here, we are still having more of liquids than we have of vapor. So it means it is not saturated yet. So it's unsaturated. Now in this one, it says the temperature of the vapor varies. This also does not support the theory behind saturated vapor. And then finally, it says the vapor pressure is atmosphere. This is just describing boiling point and not saturated vapor. So we stick with our answer, which is option A. This question starts with some readings. We have the dry reading day 1 as 30 degrees Celsius, day 2 as 29 degrees Celsius, and day 3 as 25 degrees Celsius. Now on the wet bulb, we have day 1 as 22 degrees Celsius, day 2 as 22 degrees Celsius, and day 3 as 21 degrees Celsius. Now we are told that the reading are for 3 consecutive days from a wet and dry bulb hygrometer. So it then says it can be concluded that the relative humidity for the 3 days, now we have 4 options to pick from. Now A is saying that it decreased steadily, B is saying that it remained unchanged, C is saying it increased steadily, while D says was least on day 1. Now, how we tell relative humidity using the wet and dry bulb hygrometer is by looking at the temperature difference of the wet and dry hygrometer. Now, if the temperature difference is very high, that tells you that evaporation is taking place more rapidly, and as such, the air is has very little humidity. That's the least humidity you can get, or lesser humidity. Let me put it that way. And then when you have a closer temperature from the wet and dry bulb hygrometer, that tells you that the air is more humid. In this case, that is, there's more water vapor in the atmosphere. So let's look at the temperature difference and then make our conclusion. So if we come like this, now day 1, day 2, and then difference. Oh, this should be wet. Let's make this dry rather. Dry. Let me correct this. Dry and then wet. And then the difference like this. Better. So for day 1, the dry says 30. The wet says 22. Now the difference here is 8. Now day 2. Day 2, the dry says 29. The wet says 22. The difference is 7. And then day 3. For day 3 now, we have dry 25 degrees. And then wet is 21. And the difference here is 4. So what we see here is that you see that the highest difference here is at day 1. That this one is less humid, and then it becomes more humid as you go downward, because the difference is you are saying that we're having less difference, right? So that is, the air is becoming more humid from day 1 to day 3. Now, this would mean that the humidity is increasing steadily. Now, you may also have an argument that says that D should be the answer, saying that we have the highest difference here, which tells us that this is the least humid we could see from these 3 days. That is, the one has the least relative humidity. Now, that is also correct, but the reason why we are going with C instead of D is this. Now, when we consider, you see that there is a particular pattern here. We are seeing that the difference is reducing as you go down here. So it is a pattern, it shows us a pattern. So we will choose the option that gives us a pattern rather than one that just tells us about one of the days. Now, if it were a case where we have random differences, like if this were 8 and then this is like we have 9 and then this one is like 14, they are different, like they are so different, there's no pattern. Like you are saying maybe 17, then you drop down again and then it increases again. In that case, we would have just picked the one that has the least or the one that has the most if we find such in the option. But here, because there is a pattern, that is why we are going with option C, which says it increases steadily. So option C. The temperature at which the water vapor present in the air is just sufficient to saturate air. Now, this is a point that is known as the dew point. That is the point when the water vapor in the atmosphere is just enough to saturate it. Because once it goes beyond this, then it begins to condense and then form what we know as dew. So that is known as dew point. So our answer is D. You do not want to enjoy all of this all by yourself, so please, we are pleading with you, ensure that you do share the video with as many who are also preparing for the exam. Let's help others also score high grades in their Jamb physics. So please share the video, like the video, and also if you have any question at all you would like to ask, if there's a particular question during your study time that is giving you a little bit of problems and you don't quite understand, so please, you can discuss that with us in the comment section, as well as any other comments and recommendations you have for us. Please put them in the comment section and we'll definitely attend to all of your comments. So please don't forget to like, don't forget to share, and don't forget to subscribe to the channel by clicking the subscribe button and also hitting the notification bell icon so that you get notified every time we put out a brand new content for you. Now, in this question, we are asked, what happens to a pool on a day when the humidity of air is very low? Now, when humidity of air is very low, it means that the water vapor in the atmosphere is very low, meaning the air is dry. So, when the air is dry, what will happen to a pool? Now, we know that the dryness of air actually aids evaporation. That is, the drier the air, the faster the rate of evaporation. So if you have a pool on a dry day, evaporation will be very rapid. So looking at the options we have, we're going to go with rapid evaporation, which is option D. In this question, we are asked that the saturated vapor pressure of a liquid increases when, and then we have options such as temperature of the liquid is increasing, temperature of the liquid, volume of the liquid increases, volume of the liquid decreases, and temperature of the liquid decreases. Now, for a particular liquid to get to saturated vapor pressure, it means that, remember that at saturated vapor pressure, that is when the pressure of the liquid is the same as the temperature, the pressure of the atmosphere. So when these two are the same, the liquid has been able to get to what we call the boiling point, right? And to get to the boiling point, you have to continually increase temperature. So that tells us that the saturated vapor pressure of a liquid will increase when the temperature of the liquid is also increasing. So our answer here is option A. Now, this question is similar to one of the questions we've answered, but in this one we are asked that vapor is said to be saturated on top of an enclosed liquid if, so that is, we're looking at what point is the vapor on top of a liquid said to be saturated. And we did explain in the other question that looks just like this, that when we say that we have reached a saturated vapor, it means that the quantity of molecules that is becoming vapor per second is at equilibrium with the number of molecules that is also condensing back into the liquid phase. So there has to be equilibrium there. So that is, the amount that is becoming vapor must equal the amount that is becoming liquid at the same time. So that is, the rate of evaporation, or rate of vaporization rather, is equal to the rate of condensation. And that is what we see in option B, which says the rate of condensation is equal to that of vaporization. So we go with option B. Which of the following instruments helps to maintain the correct humidity and temperature of a building? Now, folks, please, if you're yet to be subscribed to the channel, I would like to implore you to please do so, because when you subscribe to the channel, you are helping us to be able to make more helpful contents like this. So please subscribe, and also don't forget to like and share the video. We want to ensure that this video reaches as many that are in real need of content like this. So please keep sharing, and also if you have any thoughts or question whatsoever, please put it in the comment section, and we promise to definitely attend to every one of your comments. So keep them coming. We'll definitely attend to yours. Now, in this case here, we are trying to pick an instrument that will help us regulate the temperature of a building and also keep it at the level of humidity that is preferred, right? So when we look at all these options here, for air compressor is supposed to provide air at a specific pressure. Refrigerator is supposed to keep items cool, right? And then air blower is to provide air given the kind of pressure that you would like the air to come in. And then the air conditioner helps you to take hot air from a room and then replace it with a cool air that is at the right temperature and also the right humidity level. So, and because this question requires that we keep the temperature and humidity of a building. Now, the keyword there is of a building. So we are not looking at of items. If it's of items, then we could be thinking of refrigerators. Like if you want to keep your drinks cool, if you want to keep your food fresh and cool as well, you would use a refrigerator in that case. But if you want to keep your room, that is an enclosed space, cool, right, and at the right humidity, we'll be using air conditioner. So the option here is D. This question says, the process whereby a liquid turns spontaneous into vapor is called. That a lot of students just read it fast and then immediately go to their answer without giving it a second thought. However, there is a trick in this question. It says liquid turns. Now, many students will read it and their mind will immediately go to sublimation. But take note, sublimation is when a solid turns into vapor spontaneously without passing through the liquid phase. But in this case, we are looking at a liquid turning into vapor. So it is not sublimation, but in this case, it is evaporation. Now, for liquid to turn into vapor, there are two ways by which it can do that. It's either the temperature is increased until it gets to the boiling point and then it's converted into steam, or it is converted to vapor at the normal atmospheric temperature, right, due to a process known as evaporation. Now, in this case, you see that the liquid does not need to get to the boiling point, but yet it is converted into vapor. Now, that is why this definition says it turns spontaneously into vapor. So that is why we are picking, in this case, evaporation. Now, to those who do not know what rigidation is, that is when ice, for example, is brought into liquid phase by application of pressure, and the moment you take away that pressure, it immediately freezes back. So if all these options, the one that describes when liquid turns spontaneously into vapor is evaporation. The mass of water vapor in a given volume of air is 0.05 grams at 20 degrees Celsius, while the mass of water vapor required to saturate it at the same temperature is 0.15 grams. Now calculate the relative humidity of air. So we're going to look at the ratio of the mass of water vapor in that given volume of air, and then we multiply that by 100% to get the relative humidity in percentage. Solution. Relative humidity therefore becomes, now the mass of water vapor in the volume of air at 20 degrees Celsius, which is 0.05 grams, divided by the mass required to saturate it at that same temperature, and that will be 0.15 grams. Grams cancel grams easily, so multiply by 100%. Now, when we break this down, this goes here once, here thrice. So 1/3 will give us 0.3333. So multiply by 100%, and then the relative humidity is 33.33%. So the correct option is C. Which of the following is common to evaporation and boiling? So option A says that they take place at any temperature. Now, we know evaporation takes place at any temperature. However, boiling takes place at a specific temperature known as the boiling point. So definitely they don't have A in common. Now, B says they are surface phenomena. Evaporation takes place at the surface of a liquid, but boiling takes place throughout the entire liquid. So they do not have this in common also. Now, C says it involves change of state, and evaporation is when liquid becomes vapor. That is going from the liquid phase to the gaseous phase. And the same thing to boiling. The liquid is changing from its present state, which is liquid state, to a gaseous state known as vapor. Now, for D, we see that this takes place at a definite pressure, and this is what we have for boiling in this case. This one describes boiling only. They do not have it in common. So that leaves us with just the C, which we have just explained that both of them involve a change of state. So we go with option C. If a room is saturated with water vapor, the temperature of the room must be. Now, when a particular place is saturated with water vapor, that means that you're at the point where the vapor then saturates the air, then definitely that point is known as the dew point. Because dew point is defined as the temperature at which the water vapor in the atmosphere saturates it, right? So at that point, we call it dew, the dew point, because beyond that, dew begins to fall. So looking at the options we have at 0 degrees, B says above the dew point, C says at 100 degrees, but D says below or at the dew point. So that means the correct answer in this case is option D. Now, folks, you can practice with many more questions that you can also find on the Exam Fun app. So please click the link in the description box that will take you to either the Google Play Store or the Apple Store, where you can download the Exam Fun app and make your learning experience really fun. It comprises of so many subjects, so you can pick any subject of your choice and have fun while you learn different things on those subjects. And also, please do not forget to subscribe to the channel. If you have not subscribed, come on, it's only going to take a second. Hit the subscribe button, click the notification bell icon so that you get alerted every time we put out a new content for you. And do not forget to share the videos amongst your friends. Don't enjoy this all by yourself. Please ensure that you share it amongst your friends so they too can have access to this. I want to ensure that we reach as many as possible who really needs this content. So please keep sharing. And if you have any question, any recommendation whatsoever, please put them in the comment section, and we promise to attend to every one of your comments. Thank you very much for following this series so far. I'll see you in the next video.